It's just distance from a point to a line. And we've done things like the distance formula and stuff. And that's basically what this is the distance formula. But we can go over maybe tomorrow for more so for fun's sake, like why, because I had this section for tomorrow as well, like why this comes out, because I hate just giving you guys something and saying this is what it is. And that's exactly what I'm going to do here. So if you're taking notes, I'll give you some time to write this equation down. So the following formula can be used to find the distance from a point at xy. So xy, or not xy, x1, y1 is our point, to a line with equation ax plus by plus c equals 0, standard form. Usually the c is on this side, but they put it there. Like I said, we can derive this formula later if we want. Essentially, it just like we've been working with like this normal line that's perpendicular, and then essentially they take the point you have, this like x1, y1, right? Maybe the point 3, 4, who knows? And they construct a parallel line, and then they find the distance by adding in between them. It's not too bad, but I didn't feel like it was worth the explanation today. I felt like I just wanted to get through the 2 examples. That way you guys could do the 3 problems of homework that I gave you. That's it, only 3, right? So maybe I'll just leave this up there for an extra second in case we have someone that likes to write down all the words. And the book also did something weird. The book has this for when we're talking about application problems, but it says distance, and to me, distance is always positive. So the book gives us like a plus or minus down here and doesn't give us absolute values up here, but we know distance to be always positive. So I don't understand or like what they do, but so I've just done distance is always positive, right? That's what the absolute values are for. And the square root, you can't take the square root of a negative number unless you're in a different plane of existence. So we're just going to only deal with the positives, right? That's what absolute value is, right? Distance from 0, because distance can't be negative, right? If you go from home to school and then home to school, you didn't go 0 distance, right? Because you can't have a negative distance going back the same way. You've gone, if it's a mile to school, you've gone 2 miles. You haven't gone a mile minus a mile, right? So just 2 examples, and they are not bad. So find the distance between P4, 5 and the line with equation 8x plus 5y equals 20. And all we're doing is following this. So we have t equals the absolute value of a, x1 is the point, plus b, y1, right, all over the square root of a squared plus, I should have those numbers. I don't know why I'm not putting it down. 8 squared plus 5 squared, right? And we also have, it's because I know. I had a thought in my head. I just wanted to rewrite this. So a squared plus b squared. So that's what we're using, and we just have to fill it in. We know a is 8. We know x1, our point, is up here with this point at 4. Plus b is 5 times y1, which is 5. And then real quick, it wants it in this form, right, where the c is on this side, right? We want equals 0 on this side. So our actual c is negative 20. Right, because here it says plus c, but if we have minus 20, it'll be minus 20. The little details will get you in math. And then all over the square root of a squared plus 5 squared. Okay. So for the top, it's 25. I'm getting 37 in the top, all over h squared. Oops, that's the square root. 8 squared plus 5 squared is 89. All over the square root of 89. I don't think 89 breaks up into anything nice. And so, hey, the old saying that I like to say, we've invented fire, right? We have the wheel. We are not cavemen, so we rationalize. If we'll come back, there we go. So to rationalize, we have to multiply the top and bottom by the square root of 89. Again, hey, the reason we can do this and we're not changing anything because the square root of 89 divided by the square root of 89 is 1. Multiplying by something by 1 doesn't change it. 37 times the square root of 89 all over 89. And I don't believe 37 and 89 reduces at all unless there's some weird number. So that will probably be our answer. So that's the distance between this point and this line. I'll leave that up for a second in case anyone is still copying down. It's really, I mean, I think it's boring because it's really just following that equation and plugging stuff in, right? So if you can plug numbers in, you're A-okay. Okay. Does anyone need more time? If so, do not feel bad to ask for it. You could always go back at the end as well. Okay. Example 2, find the distance between the lines with equation 6x minus 2y equals 7 and y equals 3x plus 4. So distance between lines is kind of weird, right? We know that these are parallel lines, right? Our slope here is 3, and if we were to solve for y here, we'd move the x over. Minus 6x divided by negative 2 is going to be positive 3. So they are parallel. So no matter what point you pick, it's going to have the same distance to the next closest point on the line. You guys, maybe I should, just for clarification's sake, right? We have two, I'm going to do a very rough sketch. If I do two parallel lines, right? If I pick a point, any point on this one, right, it's not going to be farther away than any other point is, right? They're all going to be the same distance away. So we can kind of pick any point on the line that we want. And hey, this slope intercept makes it really easy. When x is 0, y is 4. Right? X is 0, bang, that wipes out, y is 4. And so again, look at that. We have a point, we have a line, right? And the reason I left this one, and I use this one for the point, I mean, the y-intercept is probably the easiest point to get. And then this one is almost in the form we like it to be in. We're just going to subtract that 7 over. Can I do that again? The point or the parallel line explanation? the point. Oh, okay. So when we're doing, I should have kind of maybe prefaced this with when we had this, right? The formula can be used to find the distance from a point, right, to a line. And so since I got two lines that are parallel, it doesn't matter what point I pick, but so I just need to pick a point on the line. And looking at this y equals 3x plus 4, I see the easiest way to get a point, right? Really, you can plug in an x value and find what you get for y, and that'll work. But the y-intercept being 4, right? Y equals mx plus b, that's going to be at 0, 4. You can either think of it that way, or when you plug in x equals 0, right? 3 times 0 is 0, and then the y value you get is y equals 4. How do you know they're parallel? If we were to solve for y in this top equation, right, we would subtract 6x, and then you get negative 2y equals negative 6x plus 7 divided by negative 2. So you get y equals negative 6 divided by negative 2 is positive 3x minus, and we'd have 7 halves. Same slope, different intercept. Good questions, good questions. I know that sometimes I like explain things without writing them down. And I know it's very easy to like, I'm sure a million other people probably had that question. So good job for asking. Sometimes in my head, I'm just like, let's get through it. But good questions. Because in hindsight, I did probably go over that kind of fast why those are parallel. Anyway, so I'm just subtracting that 7 over so that we're in this ax plus by plus c equals 0 form. And then again, we're just following that d equals the absolute value of a times our x point plus b, or b, which is negative 2 times our y point plus c, which is negative 7, all over the square root of a squared, so 6 squared plus b squared plus 2 squared. And that's just following this, plugging it in, right? A is what goes here. X1 is the point that we have. Y1 is the point that we have. So I'm just plugging stuff in. And then again, at this point, completely computational. This goes away. Negative 2 times 4 is negative 8. Minus 7 is going to be the absolute value of negative 15 or positive 15, right? If we have the absolute value of negative 15, it's going to turn into 15 all over the square root of 40. Does 40 break down into anything nice? We have 10. Yeah, it does. 10 and 4. What's the saying that you guys learned? You need a partner to break out of jail. 4 is 2 squared, so 40 can be reduced to 4 times 10. And that 2 can come out as, or that 4 can come out as a 2. And you're left with the square root of 10. And then again, we're not cavemen. So we rationalize. And we'll be left with 15 square root of 10 all over 2 times the square root of 10 times the square root of 10. We can do square root of 10 times square root of 10, which is 10, times 2 is 20. And then lastly, 15 divided by 20, they can both be divided by 5. So 3 square root of 10 over 4. should be our last answer.